Hello, my name is Dionizije Fa, and this talk is based on the work in progress by me and my collaborators Tomislav Šmuc and Frat Subek. The title of this talk is Graph Attention Network-Based Representation Learning for Cancer Drug Response Prediction and Interpretation. I'm going to present an interpretable deep learning model for predicting the sensitivity of in vitro cancer cell lines to drugs. The point of this research is to discover most predictive genomic factors to be used in precision medicine, where the goal is to design new therapies suited to individuals' genetic makeup. To date, many in vitro cancer cell lines have been cultured and a large number of pharmacological profiles have been measured. There is hope that the drug response of these in vitro cell lines can be effectively correlated with patients' response to drugs. Our work is based on the in vitro part of the process, where we try to model drug response of in vitro cell lines based on their genomic profiles. However, the question arises, which genetic factors are most predictive of drug response? With new technologies being developed, protein-protein interactions are starting to become targetable by drugs, although there are still many challenges. In short, drugs can have an effect on protein interaction pathways and can influence protein hubs, thus making them suitable anti-cancer therapies. To that end, we developed a multimodal attention network model which predicts drug response based on input molecules and cell lines. The cell lines are input to the model as a PPI network of cancer landmark genes that are featurized by copy number variation, mutation types, and gene expression. The input molecules are featurized by adjacency, distance, and node feature matrices. This architecture allows us to interpret the model through the learned attention coefficients both for molecules and cell lines, that is PPI networks. Attention coefficients learned by graph attention layers represent the most important edges on the PPI graph, and hopefully they can represent biologically relevant interactions. When predictive negative log of IC50 values, to our knowledge, our model improves on the state-of-the-art model DeepCDR. These results are based on a randomly drawn test set which produces results that are too optimistic. When evaluating these models based on more realistic settings, such as predicting response to cell lines or drugs that are not in the training sets, the models, including ours, perform considerably worse. The blind cell task is the one that corresponds to the precision medicine setting. We have approved therapies with measured pharmacological profiles, and we wish to predict the sensitivity of the patient's cancer to the available therapies. In this setting, the model achieves good correlation between the predicted and true values. When predicting the response of cell lines to drugs which are not in the training set, the models are unable to achieve any correlation between true and predicted values. This can also be seen from the scatter plots, where it is obvious that predicting the response of unknown drugs is not possible using this model and dataset. To investigate the landscape of the learned importance of protein-protein interactions, we reduce the vector of the attention coefficients to 2 dimensions using UMAP. From the plots, we see that the clustering is preserved across all datasets and that blood cancers appear in isolated clusters in all cases. Some cancers, such as blood cancers, share more interactions across disease tissues than others and are clustered closer together. We have also found that adding additional graph attention layers reduces the overlap between the interpreted PPI interactions without the increase of the predictive power of the models. We looked for correlation between the most important interpreted PPI interactions and the relevant literature. As an example of found interactions, we have found that ERBB3 serves as an important interaction hub in laryngeal SEC. GLI2 and USP7 interaction, a promising drug target, has been found as one of the most important interactions mediating drug response in colorectal adenocarcinoma. Checkpoint kinase 1 and 2 interactions, which could be potential anti-cancer therapies, have been assigned high importance in blood cancers, according to our models. Moving forward, we expect to investigate the robustness of the interpretation of attention coefficients to different factors and to devise a systematic way to evaluate the validity of the interpretation. Some of the factors that can influence the interpretation of the attention coefficients are training procedures, different features used when constructing cell line representations, chemical and cell line spaces. Thank you for listening.